Hello, IED, and welcome to your next video lesson on friction. So today we're going to be talking about PLTW activity 4.2.3 and how we can use some things to fight against friction. Now, friction is not always a bad thing. It's what keeps us standing. It's the thing that allows us to walk, right? If we didn't have some friction, then we would just slip and slide. Imagine trying to stand up or walk on ice, right? There's less friction on ice than there is on the ground, so it's harder to walk because you tend to slide more, right? You have less friction. But there are some instances where we want to fight against friction, where we don't want to have as much friction, and one of the things is in the toys that you're building, right? So you should be somewhere in the middle of building and designing those toys. And there's a lot of friction going on there. So we're going to investigate some of that today and talk about how we maybe can reduce some of it. So I want you to log on to PLTW activity 4.2.3. And again, in the play posit, I am going to stop occasionally and ask you questions. And when I do that, you should answer them in the play posit. Most of them are going to come directly from the PLTW website or from an activity that I'm going to ask you to do. So as you go into 4.2.3, go ahead and scroll down, read through the goals, and look at the friction and mechanical design information here. And we're going to really look at the definitions here, right? So I want you to pause the video for a minute and take a second and read through these. Make sure you understand what the difference is between static, sliding, and rolling friction. And if you need a better definition or a more succinct definition, you can click on the green words here and see those definitions. So pause and read through those. Okay, you should be back from the pause, and I want to talk about them a little bit. So static friction is when two surfaces are not moving, right? So I'm going to use my my tape example here, right? So this has static friction, right? These two things are not moving. And even if I tilt it a little bit, as long as they're not moving, that's static friction. That static friction is holding that tape in place, right? So there's friction there. It's holding that tape in place. Now when it starts to move, right, I have sliding friction. So as this starts to move, there's still friction. There's still some force there opposing that piece of, or that roll of tape, but it's different. It's a different type of friction than is static friction, right? And then the third type that we talk about is rolling friction. And that is what happens if I have a wheel or something like that that's rolling down a surface. That's rolling friction. So just think about it for a second. Which one of those do you think is bigger, right? Because they all have a coefficient of friction. They all have a force of friction, right? So this one, static friction, right? It's got one coefficient of friction. As it slides, it's different. And as it rolls, it's even more different, right? So think about that for a second. Which one do you think is going to be bigger? So what we're going to talk about relative to friction for your automata toys is how we reduce some of that friction, right? Because you have a lot of friction in there. So I'm going to pause the play posit, and I'm going to ask you to identify some places in your automata toys that you have friction. So pause. So answer the questions in the play posit. All right. Once you've answered those questions, I want you to scroll down. Again, we're still in 4.2.3, and roll down to friction reduction, and read about some of the ways that we can reduce the friction of something, right? So we can add something called a bearing, which is a way to reduce friction by changing the sliding friction into rolling friction, right? So you have less frictional force there. And if you have a fidget spinner, have you ever seen a fidget spinner, which I'm sure you all have, you know that those have bearings in them, right? Those are those little ball bearings that allow them to move very smoothly. Sometimes you can smooth the contact of a surface, right? You can use sandpaper or something like that to change how much friction there is between the surface, right? A rough surface will have more friction than a smooth surface, right? So if you want to reduce the friction, you can take some sandpaper or some steel wool or something like that and reduce the amount of friction on a particular surface. And you can use mechanical methods as well. There's a thing here called a bushing, which will reduce the friction of the material, right? So it basically changes the material for something that has a high frictional component and changes the material types to something that has a less frictional component, right? And we'll do that a little bit with your automotive boxes. Design and machining can also help, right? If you do something to really close tolerances, often it will reduce the friction. And then the last thing that's mentioned in here is to add lubrication between contacting elements. And this is what happens in your car, right? So you have to put oil in your car because there's a lot of friction, a lot of heat being generated in your car. And that's why you have to put the oil in, right? It allows lubrication between the parts of your engine. So read through those. And then now I'm going to ask you to answer the questions in Play Pause.